Alrighty, boys and girls of Rocketry, welcome to my little presentation on ground support. Today I'm going to go over a little presentation on what ground support is, why it's cool, why we do it, why I've been working on it for the last 3 years like a maniac, and then I'm going to do a little full stack skill dev get everybody used to stack. Hopefully everybody will follow along. I will not be going over the developer installation. Follow the guide for that, either the Docker way or however way is implemented. Yeah, so just gonna jump right into it. So here's ground support. Here's our little logo. So the reason why we went to making ground support was because our old ground station was very outdated. It was basically just this Pelican case, which is like just a really rugged looking case with a very with a custom-made computer. Unfortunately, we did not need that because we could get all of our telemetry data with just a USB stick called RTL-SDR. Basically, we plug this little USB stick into our computer. It has a little attachment, little coax cable attachment that attaches to our antenna, and that's all the external hardware we needed. So we decided why make a whole hardware solution for that when we can port it around to any laptop with any RTL SCR attached. So that was the goal motivation for creating it. So what it is a telemetry visualization tool, a trajectory analysis tool, post-flight analysis tool. It's designed to be modular and dynamic. So what that means is you put in a rocket, or you can have a different rocket with different payloads, different things, and you can configure it however you want. Um, how ground station is made, that's kind of allows for that. Um, yeah. So here's some screenshots of what the app looks like at this current moment after a Launch Canada competition. So we have the data config panel over here, which shows basically how you can configure all your payload, all your specific values. And then there's a details tab for your rocket, a details tab for your missions. So you can have multiple missions per rocket. You have a components tab, so you can configure multiple components and separate different components with different data configs. So like you could have your flight computer and you could have a payload, and those are two separate things that operate separately, so they're different components and they have different hardware on them, so they have different data configs. And then on this side here we have the active flight views. First is startup, so this is when you're on the pad just trying to see if things are active. So you'll see all the things from your components that are active or failed. Here's an example here, and you'll have see incoming packets from your RTL-SDR. Next, you can see the flight report. So happens after you're done your flight. It'll show you basically a bunch of data on graphs, and you can also upload data and get it to show in these pretty graphs if it is in a CSV or a .bin. .bin is a binary file, but the protocol is defined by us, so you have to use our protocol in order for it to display properly. And then there's also a recovery view, which shows your launch location and your recovery location. So here's kind of the current state of the rocket, of the ground support. In the future, there's going to be a lot more things going on here, but I'll get into that later. All right, so I'll have this presentation linked so people can click on the links on it. But here is kind of what happened at Launch Canada 2023. I presented this project ground support for the whole conference, one of the days, and then so you can get that at this link here if you click on this, and then ground support itself did pretty well. We had a limitation with our antenna. The antenna we used was an egg beater, did not have great gain, so we didn't get that many packets during actual flight. As you can see here, we only got 1, 2, 3, 4, 5, 6, which is quite sad. However, however, that can be fixed by using our Yagi antenna, or just making a better antenna for longer ranges. We also have the three packet bug. This one was not so fun to learn of. Basically, only the packets would only display after we got three of them in a row. Very weird bug. Something to do with how we were scraping the packets from the shell script. This was using Python. We were moving away from Python and moving to Rust. So hopefully that'll change with our updated microservice. All right, so projects this year for 2024 and so on. I'm assuming it'll probably go past my graduation. So one thing we are going to do is controlling our hybrid engine. That's something I'm looking into with the direct studies. Um, and then we're going to make an analysis engine. So that's going to do a trajectory analysis, allow you to spec a rocket and do a bunch of little simulations. Right now we have a little spreadsheet, so we're just going to port that spreadsheet over into a little microservice. We're going to do a database replay. So basically, what that is just replaying your old missions, see how they did, see how they looked. And then we have telemetry. That's just switching from Python to Rust. Same sort of thing, just switching to Rust. Um, yeah. So here's an overall overview of the rock or the of the ground station. So starting from the rocket end, the rocket will send packets out. Our Yagi antenna, that's what this is, will pick it up. It'll connect to the RTLCR, send the waves over to our decoding module inside our telemetry. It'll decode it, and it'll get these little packets. They'll look decoded, look something like this. Then the packets will be sent off to the socket gateway. The socket gateway will send to the API or to the front end, and then the API will save it in the server, and the front end will display live actions of what you got. And then the front end can also talk to the server by the server's API. So that's the general overview of kind of what ground support looks like and how it works. Here's a little nitty gritty, similar sort of thing, but a little bit more. So rocket, telemetry, sockets, socket context. This is a file in ground support or in the front end, and then directly to the client, and then client can talk to API, set all this entity endpoints and stuff like that. All right, so quickly going to talk about some microservices. So microservices are very are independent services in the code base. So they're things that can act independently of the app itself. They're not coupled to anything. So for us, we have the application and telemetry. Telemetry itself is it's being swapped out right now, and we're going to be adding analysis. That's why it's kind of grayed out because it's not made yet. But the application is the server and the front end, or the server and the client in the code base. Those two things are coupled because without the server, you cannot render anything on the front end. So it's pretty important to have to have the server. And then for the telemetry, it can just be swapped in and out, and analysis can be swapped in and out for any other engine. Um, so that's what makes them microservices. Yeah. So Docker, we're using Docker. Very fun. Standard environment that our code runs in. This means it can run on anybody's computer by just having the Docker environment available. So you can download Docker, and you don't even have to do any funky commands to install anything. You can just hit this Docker compose up, and it will make our microservices and run them for you on your computer without you writing any commands. So this is really nice. For one, we will all be working in the same environment, won't deal with the same errors, or won't deal with like these OS errors with things not working cross compatibly. But since it's a web app, that's not normally a problem, but this is very nice. Also allows us to just run with one click rather than like 7 terminals, because before we had three terminals in telemetry, 2 terminals to run the application. So it was a lot of terminals. So now you just click a button and it runs. A lot nicer. All right, gonna jump into the front end here. So the front end uses TypeScript, which is a superset of JavaScript. It uses React and it uses MUI and Axios. So MUI is our component library and Axios is our API kind of framework. Um, It's just like a wrapper that makes it easier to use requests and sort of stuff like that. And if you haven't heard of React, it's basically like a large framework library built on JavaScript. It's basically a language in itself, some people call it, because it's so big and does so much. But it's basically makes our job as web developers a lot easier. All right, quickly going over the overview of what we're doing for what we do for the front end. So our design methodology for the front end is dynamic UI. So it means it responds to the whatever our data looks like. So nothing's statically sized or statically generated. Everything is made to be dynamic. All right. Hopefully that's pretty straightforward. And then MUI. So there's no custom CSS. We are only using the built-in utilities of MUI and the built-in components that you can see here. Here's a bunch of variants of buttons that they give you, and they're over here. You can add on CSS afterward, but they should only be done in a way through MUI's library rather than making your own custom CSS. That's generally how that's handled. The reason for this is because we want the app to flow very nice together. There not to be any inconsistencies in style. So this alleviates that. All right, so just quickly React basics. So the framework is MVC, which is a model view controller. There's a whole bunch of frameworks out there. You can look them up, but it's only pretty important to kind of. It's not that important to know how React works if you don't know how it works. You can just kind of like dick around with it and hope it works. But React itself is, if you want to kind of understand the nitty gritty, this is how it works. So you have views, models, and controllers. The view is what the user sees. So this is where this user action comes in. The model is kind of where all the data is seen. So when a user action happens, it'll tell the controller to update the model, which is then bound to the view, which will then update the view. So the controller updates the model, which will then bind to the view. So it's just kind of like a big cyclic process to how things update. You can read a little bit more about this online. There's a lot of good resources about it if you're not completely sure from my little description there. Okay, so I'm going to just talk about React component lifecycle because this is pretty good to know. Inside of the web browser, there's this thing called the DOM. The DOM is basically our overlord. It controls all of our little HTML elements, so everything that kind of gets mounted and unmounted in there. So the first thing that happens in the DOM is we will construct. So think of it kind of like object-oriented programming. You have a component, and you can have an instance of a component. So the constructor will make it. That's what the construct is. And then you have a new state. If you get new props, new state, or force update, these are different hooks, as they're called in React, that will update state. And then they'll trigger a render, which then says, "Hey, DOM, update these references to the new things that I just made, which I just rendered." So then it'll reattach to new things, and then it'll say, "Did I mount? Did I update?" That sort of thing. And that's kind of the cycle that it goes through. If you get more state, it'll render something new, reattach it to the DOM, and then mount. And that's kind of how it works. And then for unmounting, it just gives you a trigger when it's unmounted. All right, so here is kind of what a component looks like in TypeScript React. If you're not really used to TypeScript or used to anything like that, this is actually I called it JSX here, but JSX is React's way of putting all of your web dev things in one place. So in here you have HTML. You can see by these angle brackets right here. You have logic, and it's all wrapped in this one big function here. And then you have an interface up here that describes the props that go into the component. Props are like properties or parameters that you can change things about the component itself. Think about it just like parameters to a function. And you can also add CSS and styling in here, but since we don't use it, it's normally just used as classes on our HTML elements down here. So all this, so when you first see this, is a lot to look at, but this kind of shows you generally what's going on. with JSX, which is used everywhere inside of React. Okay, so just want to quickly look through the client structure. So inside the structure here, we have components and views. These are the two main things that we'll be talking about. Components are made to, they're like blueprints that you can render a bunch of things of. So on websites, you normally see like a bunch of repetitive things like buttons, and most of those are going to be components. And you just pass in different states, like the title of the button, and then it'll just change to a different title. And you can make multiple of those. And those will be hosted inside the view. So the view is basically what you see on your viewport. Um, is all the view holds all your components. That's normally the best way to think about it. And then there's a bunch of other things like style, statics, utilities, and the root and the services. Services is where the API is held. I'll get to that in the full stack or in the Skilldev. Yeah, yeah. Here we go. Just talking about the API. So we have an API wrapper that I made a while ago. So basically, this wraps around Axios itself because Axios leaves a lot of ways to make things, but in our app, we want it to be consistent because a lot of people can use APIs differently, but it'd be nice if everybody used it the same and got the same objects because of it. So on the side here in our response type, we have a data and error. So in data, we have all the acceptable types that you can get from the API. So you can see there's a bunch of types. There's one for a normal get. There's one for a get all. There's one for populating all the attributes. And then we have an error. So this will over here, it'll show you the error. So if there's an error or not, it'll show you the status number of an HTTP request, message and all that. And then Axios request. This is kind of what comes in if you look in your network tab in your debugger. So it's your F12. If you look in that and look in the network area, this is usually what an Axios request will look like. It'll have data, status number, headers, configs, requests. These are all the things that come in a normal HTTP request. So you'll see those a lot. And then in the actual front end, this is how you'll use it. You'll import the service, and you'll import the entity, and then you'll make a function that will just use the get, or for this one, use the get, and then it'll get the data. You have to typecast it to the actual type that you want, and then you set it. And then that'll be the same for basically any endpoint that you use in the API. It's that simple. It's just 3 lines in order to use the API. Yeah, so that's pretty much how that works. Yeah. All right, let's talk about the server now. Server. This is also made in TypeScript. It's using MongoDB, which is a NoSQL database, and it's using Express, which is the thing that connects to the database and makes the endpoints and everything for us to interact with it. So our design and methodology for the backend is entity data modeling. So it kind of talks about the structure of the data rather than how it associates with each other. Um, it's pretty self-explanatory. I'll get into that a little bit more later. All right, so MongoDB is NoSQL. So everything, all the entities or all the objects look like JSON objects. So that's a JavaScript object or notation. It's very popular when you see messages being sent around on the internet, or just used for configuring things or anything. So JSON's kind of used everywhere, but they're basically like little objects. In MongoDB, all the things that you store are called documents, and they're not in a table as things like SQL would be. So they're kind of more free and the relationship is not the first thing you think about. It's more of the data modeling. Yeah, so here's kind of how the app is broken up in our entities. So at the very top, you have our 2 main entities. You have the rocket and the mission. The rocket is the main one because we're just trying to display rocket data and analyze rockets and do stuff with rockets, so that's why it's the big one. And then it breaks up into the component, like I talked about before. And then the component has a data config, and then data config stores modules, field groups, and fields. So this is just a way that we can show data dynamically, because you can have different type of fields for different components inside of your rocket. So this will just be able to allows the user to configure a bunch of different things using our dynamic UI, as we said before. And then the mission just allows you to record a bunch of different data per, like a bunch of different missions. So you can record a bunch of different data. That's what this field data is. Yeah. So let's talk about Mongoose. Mongoose is a wrapper for JavaScript that lets us talk to MongoDB directly. It's like the I would say it gives you a bunch of the functions of MongoDB. As you can see, this is a schema. A schema is what defines the basically what attributes are inside of your model. So you can see here for this one field group one, you have a name and you have fields, and then you have another schema embedded in it. So that's pretty common. You can have a bunch of things embedded, or you can have things linked by their ID. But this one's directly embedded, so it won't populate its own document. It'll just be inside here. Um, so that's one way of doing things. Yeah. So let's talk about the design pattern. This is pretty important to understand when it comes to backend design. So you have the model, which is the blueprint of the data, so it basically describes what the data is going to look like. And then you have the controller, which is the middleman, the logic that explains kind of how it's going to save things to the database. It also talks directly to the database and sort of stuff like that. Um, the root, which is what the users interface with in order to talk to our data. So the root will talk directly to the controller. So let's say you're making an API request on a root. Let's say we're making a GET request. It'll go into our root, and then it will be forwarded to our controller. Then it will be the controller will select what it wants you to do. So if you're doing a GET request, it'll say I want to get this thing by this ID, and it'll say hey, and it'll go and talk to the models, which are then stored in the database. So then the models will grab itself from the database and throw it back to the controller, and then the controller will throw it out to you. And that's the general flow of how that works. Yes. All right, we're going to talk about telemetry pretty quickly here. It's not too much to talk about here, but we're using Rust and we use bash commands because our software for this is run in bash. All right, so same thing as before, but just a smaller diagram this time. So you have the rocket, sends you a little waveform data. It looks like got like that coming in. Gets picked up by the RTLCR. It outputs a wave. So this is why it has this little squiggly, and then we decode it. So that's basically the job of decode and then distribute. That's the job of telemetry. So for receiving, we use an RTL SCR or SCR and RTLFM, which is the software that interfaces with the RTLCR. This thing uses frequency key shifting. You can look it up. It's not too important. But that will get the data and they'll pump out like a waveform. When it's outputted directly to the terminal, it looks like a bunch of text just going up and down, and it looks like a wave, but it looks like garbage because we can't read that. So the next thing we got to do is use decoding. There are a built-in decoder for APRS packets, which is what the some of the RTL SCR outputs. And Direwolf will output it as actual nice data, which you saw over here. So it'll decode it to look like this. So it'll give you plain text that we can actually understand. Another thing that we're going to have to work on for decoding is custom packet decoding, because there's certain packets that will be coming in as bin files from, or will be decoded as bin files from the Rocket using our custom packet sending protocol, and we have to figure out how to actually decode that properly. All right, so talking about real-time data, this is how we actually connect to the client directly. So we use sockets for that. So on the back end, basically a socket works is there's one side and then there's another side of the socket. Let's say this is telemetry and this is the front end. And let's say this cord right here represents the pipe between or the socket between it. So as the telemetry over here sends something, it'll go through this wire, and then on the other side, it'll get a ping whenever that happens, and it'll know to update the state. So it's a direct connection using TCP, directly connected from the telemetry to the client. So we'll get an immediate update. Rather with an API, it'll just like send it up into the cloud, and it's waiting for the client, and the client will only get it when it requests for it. And this one is just a direct communication between the two. So in the APRS loop, we go through our RTLFM, go to decode, and then we trigger the SEO. And then similar with the LoRa, that's one option for custom packet sending. We receive a byte packet, decode it, trigger it. And then here's all those triggers that we can do. And on the other side, we have state. So this is what is connected on the front end. And on the SEO, they'll update the state. So when you get an APRS packet, it'll trigger the function that updates this variable. So that is real time. I did not write future plans. I have them, but I just didn't write them down. Yeah, so big part of this is the developer guide. Here's a link to it. Pretty cool. Developer guide will kind of go over everything you need to know in order to actually like start developing code. It'll have a little description of everything, and it'll have literal code for you to look at. Here are a bunch of projects and things that you can do. Let me know, or whoever's in charge of ground support at the time, which one you want to do. Very cool. And that is all for the presentation part of this video. Yeah. Alrighty, we're back for the skill dev. So for this section, I'm gonna go over making doing like a whole full stack ticket. You're gonna do back end, front end, everything that connects it, and a little bit of testing. So I'm gonna go through kind of all of that, so you can kind of reference this when you guys are going through your own tickets and trying to learn things. So, as I kind of said in the presentation, we got two stacks. We got the front end, which is what you see here, and we have the back end, which is our database. You can see a bunch of this is running on MongoDB Atlas. For this section, I'm assuming that you have already done your environment setup, either running through a Docker container, or you're running it through the terminal. I'll be doing it through the terminal for this one. So for this one, you'll need three terminal instances or two terminal instances. You'll need the server, the client. Actually, I have three open, just one for main Git stuff, so it doesn't clog up all my other stuff. But yeah, so quickly, just gonna go through what we're gonna make today. So here's a little preview of of one of our projects that we're working on this year. This was a older document that we found made by one of our old analysis lead, Claire. She wanted to make a custom trajectory analysis platform for a long time ago because there was a little bit of inconsistencies and it was kind of hard to use them. There's a lot of like learning curve. So, and they also just use a spreadsheet for a couple of things. So we're going to try and make the spreadsheet into a part of the app. So it's used for simulations and stuff like that. So this will give you like a little rundown of kind of all the things you need to do to make that. So for this one, for this skill dev, we're going to focus on making the input to the simulation engine. So the input, there's a list in here. If you go to, oh, that's the wrong thing. If you go to the dock here, there is a whole bunch of um, different values that we need to input. You can see there's the nose cone, there's the boat tail, there's the fins, there's the details about the rocket itself. For this purpose of making this skill dev not super incredibly long, we're just going to be inputting these values. So it'll be the rocket diameter, mass, dry mass, pressure, center of gravity, fuselage length, and total rocket length. So to do that, first thing we need to do is we're going to go to your command line and go find ground support, and we're going to make a new branch. To do that, we'll do git checkout -b and just call it full stack skill dev. Actually, you could just call it skill dev and then your name. So like that. So that'll create a new local branch on your, like basically a copy of main of the main branch, but in a new branch on your local computer. So now this won't fuck up main if you do anything wrong. Here's a little fun thing you can do. You can do code dot, and that'll bring up Visual Studio, as you can see here. Or it's Visual Studio Code if you have that installed. So now that we have Visual Studio Code in, we can go by making our model. So we're gonna start by making everything on the server side first, because that's what defines what's going to be rendered on the front end, because it's where we store all the data. So the first thing we're going to do is we're going to make the model for the input data. Just to give a little refresher on what we're going to do, we're going to make rocket diameter, wet mass, dry mass, center pressure, center gravity, fuselage length, total rocket length. So to do that, we're going to go into our file system here. I'll just close everything so I can show you where we need to go. So you're going to go into services, server, and then you go into source, and then you go into models, and you're going to we're going to do a little right click on here and make a new file, and you're going to call it rocket sim model.ts. Yeah. So inside of here, you are going to make a couple of things. There's also a very important thing, a very good thing, resource you can use here is the dev skill or the dev guide. So the dev guide has little templates on how you can make everything. So what I'm going to do is I'm going to just copy the entity one, and I'll go in and paste that in here. So I'll just explain kind of what each line does here. So this is just importing all our things that we need. The interface, this is kind of what tells us what we're kind of gives you an interface is like a Java interface. It just kind of tells you the structure of what your data looks like. And then we'll create the model over here, which will extend the entity. So first I'm going to just rename this to Rocket Sim. And I'm going to do that here as well. I'll just copy that and put that right here, right here, right here, right here, right here, right here, and right here. Okay, so those are the things that you have to rename in order for it to be your thing. We're going to have a name for the simulation name. We're going to have a dry mass. We're going to have a wet mass. We're going to have a center of gravity or center of mass. Nope, it's actually called center of gravity. The wet and dry is that means when you have the motor installed in the rocket and when you don't have it installed. Wet means the motor's installed. Dry means it's not installed. We can also have center of gravity will change determined on the wet and dry mass, but we'll just have one value to make it simpler. And then we'll have fuselage diameter, and then we'll have fuselage length, and then we'll have nose cone length. Also, all these values are capital. No, that's not right. All of these values have capitals in the front. That is how we name things in the back end, just so everybody knows. That is a convention for kind of for entity modeling. You always have the back end values capitalized. Okay, so now we can get into here. This is the schema. This is what defines what the values will look like when you save it to the database. It'll have a type, and it'll say if it's required or not, and it'll have a validator. You don't necessarily need a validator if it's pretty straightforward, but we'll have a couple of them. So the name is already set up for us, so we'll go on to the dry mass. It is going to be a number. Big distinction here, lowercase number and then uppercase number in the schema. Lowercase here because it is using the TypeScript type. And then in here, this is using the number literal. See, it's any JavaScript number. The reason we do this is because Mongo or Mongoose has a different type. But when we actually want to use it in TypeScript, it has to be of the TypeScript type, or else you get some really fun errors that you have to typecast all the time. So make sure that you always have lowercase on your interface and uppercase in your schema. As you can see, this part, the validator is TypeScript as well, so that's why we have it that. Okay, so I'll just write some validator logic. So return, actually value, we'll call it mass. Return mass needs to be greater than 0 because you can't have negative dry mass. And we're not going to send an upper bound, but we're going to say and is not, yes, is not there. That's what NaNA means. It returns a bool saying if it's not a number or not. So this is just typecasting, making sure it's actually a number. And then we'll do the same thing for the wet mass. And then the fuselage length or diameter this is not too, this is, we can also keep that. We can all keep all this logic for all of them, so it'll make sure it's all positive numbers, because you can't have a negative diameter. And then you can't have a negative length. And you can't have a, wait, nose cone length. Did I make nose cone length? Oh, that's not what I wanted. I want rocket length. And you got the rocket length. Yeah. And then let's see, is that all of them? We got name, dry mass, wet mass, center of gravity, center of pressure. Those haven't gone yet. Okay. Center, oh, it had it for a second. Center of gravity, center of pressure. And that should be all of them. So all of them can look pretty similar. Name doesn't need a validator because it's just a name. That can be kind of anything, not too important. And then the rest of this is done. So we've created our model. So now we can use this import statement in other places to use it. I'll just go quickly back to here. So just a quick reminder, we just created this part, the model, which interfaces directly with the database. So that's where this schema defines the values in the database. Now we're going to create a controller. For right now, there is one controller that is called generic. So this controller is used by all of the entities. As you can see, the input into every single one of these is a model. So that means it's able to manipulate all the models exactly the same. So all the entities have the exact same methods at their disposal for the controller. So the controller, it has 4 methods right now, or 5. We have create, get all, get, update, put, and delete one. Each of these correspond to an HTTP verb. Create is a post. Get all is just a get. but it gets every single value, so you don't need to input an ID. Get, you input an ID, and it'll get that specific one. Update, if you give it an ID and you give it something to update, it'll update it. Put, similar. We don't use put yet. It hasn't been tested yet. And then delete one. So to actually use them, what we do is we create a root. So the root is where we define all of our endpoints. So for us, we'll call our root rocket sim root.ts. So roots are pretty simple. I'll just go back over to the dev guide and look at the root. This is what they look like. They all look exactly the same because we all use the exact same methods. So our model that we're actually using is from Rocket Sim model, and it is called Rocket Sim. Oh, right, sorry, we need the curlies because we have multiple exported. Rocket Sim. And then we can paste these in here. Oh, this is weird. Delete one and just a normal get. Okay, so I'll have to update that from the guide, but basically now this associates the verb, the get verb with the get all, the other get verb with the get one, the post with the create, the patch with the update, and the delete with the delete one. So this will just connect everything. So this creates all our endpoints. So we got these endpoints available to us now. And now we just got to connect this up to our server. So we go to the server.ts file, and then we just have to add our root right here. And then we'll just call it Rocket Sim. And then we'll do Rocket Sim root. And at the top, we'll just import Rocket Sim root. Import Rocket Sim root. Boom. So that will take this root and it'll apply it to the server. So then under this URL. So now we'll be able to access all those endpoints from here. So that is pretty much all the backend right there. We went through the model, which creates the schema, which has defined everything, and which creates the model, which interfaces directly with the database. We use the generic controller in the root to define a bunch of endpoints: the get one, the get all, the post, the patch, and the delete. And then we add that to our server to expose that to the front end. All right, it is now time to test if that worked. So we're going to go into our server terminal, and we're going to run npm run server. And if everything goes good, we'll see blue lines at the end here. And boom, it's running and nothing is broken. So that means everything is good. We did everything properly. Next thing we want to do is jump into the front end. So for the front end, what we're going to do is we're going to make a simple input form. This form is going to create. Oh shit! Didn't mean to do that. This form is going to take all the input from the user and it'll post it to the back end, and then it'll also allow you to edit. So this is the front end. First things we're gonna have to do there is define our entities and define our API. So to do that, we can just look up entities.js. So that's in source, and then utils entities. So what we're gonna do is we're gonna go to our model. We're gonna grab our interface, copy it, and slap it in the front end. So this exposes it to the front end. One change is we're just going to add in the ID because this makes it useful for the front end API. So now this will expose it to the front end. So now we can use this type everywhere inside the front end. Now we're going to go to the API, and we're going to create our roots for the front end. So basically all the roots look pretty much the same. I also have a pull request that you guys can look at in order to kind of figure out to just follow along if you want to just copy and paste code. I'll have that linked below in the description. So I'm just going to go in and copy everything I did in that one because I know it works. But basically, I'll run through all the things I did in there. So here, I'll just paste that in here. Alrighty. Okay, so I'm just going to import. Okay, it doesn't want to import because I have model here. Import Rocket Sim. Boom, boom. Oh, right, sorry. Before we do that, we have to go to the very, very top. As you can see, it imported itself from the entities, and then we got to add the types of entities. We got to add Rocket Sim to here. So we'll add Rocket Sim, and we'll also add Rocket Sim with an array because you can also get multiple Rocket Sims. So now this will allow it to be used by the API. So I scroll down to the very bottom where we were before. We'll get rid of that error that we had here. So this will get all rocket simulations. So I called the function get rocket sims. It's very similar to basically all the other ones. That's why I just copy and pasted because they're all the same. And then I'll just quickly change this. This is I. Oh, this is the rocket one. Huh. Let me scroll down to the rocket sim one. Rocket sim, rocket sim, rocket sim, rocket sim. Okay. So I changed the get. Oh, I see this is actually old. So change that to rocket sim, get rocket sims. So basically you just change the types of the things and then it'll just allow you to, this will just define basically a way that we use the API in the front end. So it's all standardized because there's a lot of different ways you can use Axios, but this allows it to change a little bit. So just gotta change all the types to Rocket Sim, 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 and that should be all of them. And now we can just add those to the end here. Get Rocket Sims, get Rocket Sim, create Rocket Sim, update Rocket Sim, and delete Rocket Sim. So now all of those will be available in the front end off of this API helper file. Yeah, so now we can jump in and get started with our component. So as I said before, for the component, we're gonna create a component that is a dialog. So that's just like a pop-up, something that pops up on your window, and we'll use it as a form to input all this data, similar to like so it'll just have this as your input data. Alrighty, so let's go into components and let's create that component. So it'll be called Rocket Sim Dialog.tsx. Boom. Okay, so in here, I'm going to go back to the dev guide and grab the template code. So we'll start from the exact same point. So just go up to the front end. Oh, this is talking about the API. That's talking about a view. And then this talks about the components. I'll just copy that. Go back to VS Code, slap that in there. Use state is not imported automatically, and we don't need context. All right. So I'm just going to clean it up a little bit because there's a lot of just comments telling you what things are. So they're not particularly necessary. All right. So for dialog, you need a couple of things to control it. you need, so for our props, I'm going to add in is open. So this, what this will do, this is just a Boolean that kind of tells you whether they'll control the state of if the dialog is open or not. So it'll display it or not. You'll have an on close button, so this is just, or on close function, so this will just happen when things are closed. And then you'll also have a ID. This little question mark here means it is not required. So this ID, if we're given this ID, then we will populate the data on the dialog and update it. So this will allow editing in the same component, so we don't have to make another component just for editing. Yeah. So now we can rename the thing. So it's called Rocket Sim Model or dialog, and then it'll be changed there, and then change the props to Rocket Sim Prop Dialog props just for consistency, so everything's the same. So that'll change there. Okay, now we're going to import a couple of things. So I'm going to import the entity. So I'll grab the rocket sim, and I'll also import the API from the services, and then we'll build up all the other things slowly. So first thing we're going to do is we're just going to define all the properties inside of our component here. So the goal of our component is to basically have a form for all of these. So each one of these will need an individual state variable to deal with it. There's other ways to do it, but just for simplicity's sake, we're just going to keep it pretty verbose like this. Also, a good thing to do is to destructure your component or destructure your props like this. So this means you can just use them as normal variables. So you get ID is open and on close. So now those can be used inside of here. So I'm going to create all the Rocket Sim property states. And in here we'll have the dry mass. That's one, or the dry mass, keeping it a lowercase. And we'll give it, it can either be a number or it can be null. So that'll allow the form input to be empty when we first initialize it. And we'll just give it a null state. And then we'll do, it really wants me to do propellant mass. Copilot really wants propellant mass for some reason. And then we'll do wet mass. And then we'll do the name. And then we'll do the center of gravity. Center of gravity, and then we'll do the center of pressure, and then we'll do the rocket length. And then we'll do the diameter. We'll just call it diameter instead of rocket or fuselage diameter. And then we'll get the what else do we have? The fuselage length. Okay, now that we have all our states set up, we can go in and create create a little little array here. So this is what we'll map over. So we're gonna have a function or a object with a label. Yeah, we'll start off with name, sure. So this is the name of the text input. We'll have a value, and the value will be connected directly to the variable, the state variable. So that's name, and then it will have the setter, and that'll be set name. And then we will have the type. So this is just the type of the text input. And this one could be text. And then we can create that for every single other one. This is just easier to loop through everything. It'll just define all the things. Boom. I'm just gonna wait for Copilot to do it for me. You can just copy and paste this in from the pull request to make your life a little easier, but I'm just gonna go ahead and do it this way. um, that should be all of them. Boom. Alrighty. Okay. So now that we have all our state, we can go in and actually start creating the HTML and HTML stuff. So we use MUI, which you can use since it's already installed directly onto the project. You'll see all these like fun little things if you use VS Code. If you type in the name and then click enter on it, it'll auto import it. Just a quick little tip there. So that's the dialog. It'll connect directly to open and is close. We don't want this is close on close. We'll use a different one, and then I'll just make this variable full width. If you do not add an equal sign curly, it just means that this is truthful. And then we'll have the dialog title. Oh, what is this? Oh, I like that. Edit/create. That is smart. I didn't do that originally. Look at that. Edit/create edit/create rocket sim. I like that. Very straightforward. Did not do that originally. Dialog content. And then below that, we'll have the dialog actions. So this is like all the buttons that you normally see at the bottom of dialogs. So inside the actions, we'll have two buttons. We'll have one button for canceling, and I'll have one button for saving. These won't be those automatically. Okay, so inside of here, we'll create a stack. I'll do like spacing 3. And cannot find name stack. Let me just update that. And then inside of here, we'll just map through our Rocket properties. As you can see, Copilot's already telling me what to do. You do this, and we want a text field, and then we'll have a key, and then we'll have a label, and then we'll have a value. And then on change, we'll change the setter, and then we'll take the type, and then boom. Just gotta import this because it doesn't import automatically. Oh, I guess it did. All right, so quick little problem here. As you can see, there's a couple of curlies saying that will not work because you say string is not assignable to certain things. So we have to create a on-change handler to make that work. So I'll just put that right above here. So this is what a handle change handler. So you'll give it the state, the event, which is E, and the state function, which changes it. So this will just typecast it to a string and then set the state. So then this will get rid of this error. This is just a thing that I noticed when using this. So you just do this instead. Oh, and then you gotta do property in the setter. So now that's gone. That error is gone. I'm gonna just put this over here so we can go full screen again. Alrighty. So now we got to make a close handler and a save handler. And to do that, we're gonna make 2 more handlers. So we'll make the const handle save. This will be asynchronous because we are going to be doing API calls here. And we'll also do well, no, I'll just call it handle close so we can use it multiple times. And that won't be asynchronous because all that's going to do is that. Just do on close. Um, okay, so inside of, we'll also do load if we get the ID. So we'll do const handle handle load, and that'll be asynchronous as well. Okay, so let's start off with saving. So let's say first thing we gotta do when we're saving something, creating a post, we gotta create a payload. So what that looks like is something like this, payload, and it's going to be of type iRocketSim, and that's what it'll look like, except for we need capitals here. So all these guys need to be capitals. Dry mass, wet mass, center gravity, center pressure, diameter. Oh, no, this is going to be fuselage diameter. And then fuselage length, and then rocket length. Oh, okay. So you can see here it says null is not definable to this, so we're just going to put in these exclamation points and force it to deal with that, because nullability, the save button will only be clicked if all the required fields are clicked. So boom, put that in there. So that will get rid of all that errors. Beautiful, beautiful. Okay, we're gonna want to add one more thing in here, required. And we'll say this is only true if the property, oh yeah, we want everything to be required. So what this will do is it'll just add a little star next to it. You normally see these when things are required. So there you go. There's the payload. And now we want to actually, yes, we'll either put or, well, not put, but we'll patch or we'll post, depending on the ID. So we'll do ID. And then we'll do await API dot update update rocket sim, and we'll give it the payload. And since our I wrote playload. We don't want a payload. We want a payload. So what this will do, this will run into our API here, and it'll do where is it? The update rocket. So it'll return this. What will it return? It'll return the type. It'll have a data and it'll have error. So in order to check if this was done properly, we'll do .error and then .error. So this will just return true or not. And then we'll want to just assign this to a variable to check if it was truth, if it worked or not. So we'll do success, and we'll just say that's equal to a boolean, and we won't make we'll make that let, so it can be reassigned. And then you do that, and then we'll do else. Boom. And this will just create it. So on one hand, if you have the API, it'll update it, or if you have the ID, it'll update it. If you don't have the ID, it'll create a new one. So that's the logic, how the logic works here. There you go. And then, if successful, we want to handle close. So this way, if it isn't successful, you can't close it. Just pretty simple like that. So there you go. And then we want to create the handle load function. So what this will do is, I mean, it'll pretty much do that. But we're gonna wrap, yeah, it'll do this. Yeah, except for rocketsim.name. So one problem with the auto-generated code by Chat GPT is, or by Copilot, is we didn't typecast. We got to typecast the rocket sim. So this will be actually called a response, and this will be called the rocket sim. Oh, or you can just call it response data, and then you'll do that. So just typecast it to the proper thing, and then we'll just do that, and you'll see all the errors going away. Alrighty, so that'll load. So we want this to, however, we only want this to happen if we have an ID. If we don't have an ID, yeah, wait, what it had there, we want it to return. There you go. So this will just make sure it doesn't go onto the rest of the line, but if we do have one, it'll go over here. Beautiful. Alrighty, alrighty. Now we're just going to slap this in the use effect. Use effect runs at the beginning or whenever a value inside this array is changed. So we'll just slap that in there. And we'll say if the ID changes, do this thing. So if you ever get a new ID, do a new handle load. That'll update. Yes. Now we'll just change this to handle close because that is now hooked up properly. And then down here on save, we'll do handle save. If this button is closed, we want it to handle save. And then if it's not, we want to do handle close. Alrighty. So I think it's about time that we run this just to check for errors. So we go into our terminal window again. Here she is, just hanging out. And we go in and we go into the client one and we write npm run start. And this will run through a bunch of commands and it'll start up the server. So if it starts without a hitch, that means we did a good job. I'm just going to put it over here. It's loading. So what'll happen for you, it'll bring up a new window in whatever terminal you have up or whatever browser you have up. And it has no issues found, and we're golden. Lovely. So now what we got to do is we got to actually put it somewhere. So the component has been made. Now we actually got to make a view for it. So our view is going to be inside of this rocket details area because we want to have, in the future, we want to be able to add our simulations to our rockets. So here are some things of the rocket. We'll have the details of the rocket, the components of the rocket, and the missions of the rocket. So what we'll want to do is we'll add another simulations tab, and then we'll create another window in here that will have a button that says you can create simulations. So what that'll look like is I'll just quickly find the code from the pull request so I don't have to like go in and figure it out again. So what that'll look like, we'll have to go into rocket details view. So rocket details view is this whole view here. It's like everything you see here. And I'll just quickly go through how it kind of works. So this is just the top button. And then over here you have the paper. So paper is this bar here. And then below it you'll show the buttons. So you can see here you have a mission button, or you have a component button, or you have an edit button. And you can see the buttons are here depending on the tab value that you're on. And then you have a tab panel. So this is actually the content that's displayed below. So we have the components tab. When you're on components, that's what will show this. Currently there's no components, but on the missions tab it'll show a table. So what we're going to want to do is create a new tab here. And to do that, what we're going to do is we're going to go up a little bit until we see tabs. And then we're going to put in another tab labeled as simulations. And then we're going to want to create another button right here. And we'll call that button with a value of 3 because it's the third tab in the list, or the third index in the list. So that's how that's connected there. And we'll call it simulation. This is an add button, as you can see from the add icon. And this will trigger the dialog to show up. So we'll create a new state variable right up here. The pop-up states. As you can see, there's a couple other ones. So we do const is what do we call it? Rocket sim. Actually, let's call it is sim dialog open, and then we'll do a setter. At first, it'll be false because you don't want a million pop-ups open right away, and we'll put that in here. I'll put the setters here, and we'll set it to true. Oh, we'll set it to true if this button is clicked. And then now we can create the tab panel. So we'll make another tab panel. So this is the actual stuff inside of the tabs. We don't actually need to make a whole tab panel for this thing because we're not that far ahead in the development. So we can just say like to do, yeah, create tab. This will just, so now if we go in here, you can see no issues found. Go back over. You can see there's a simulations tab, and now we have a simulations button. Lovely. Last thing we got to do is just put in our pop-ups. As you can see, here's all the other pop-ups. They have a lot more props than ours does, but that's okay. We'll do rocket sim dialog. And we'll need to give it a is open, on closed, and an ID. However, we don't have any IDs, so we're just not going to give it an ID right now. So now, the on closed will close it, and the is open will control if it's opened or not. So this variable, this is opened prop, will connect this variable right here that we defined up here. It'll connect that to the dialog prop here. So now the two things are connected. So if we go over and we click on this, boom, look at that. There's our dialog. It has been made. Lovely. So now we can go in and actually test and see if it actually works, and we can make a rocket, or we can make a rocket sim. To do that, I'm just gonna kill that. You can click this, and let's just type a sim or make something. Let's say it's 23. We don't have values here. All right. I'll quickly add one more thing before we actually test it out. Inside of here, we actually want to have units shown, so we know what we're showing. For the name, there are no units, duh. But for the rest of them, there'll be units. We'll have, for the wet mass, we'll do in kilograms. And then for the dry mass that was. And then for the center of gravity, we'll do that in feet, because for some weird reason we like doing imperial and metric. Weird. I don't know why rockets are made like this, but they are. And then diameter in inches. Diameter is also imperial. Fuselage length, that'll be in feet. Actually, Actually, these should probably be in meters. That would make more sense. Except for that one is the other one, and then rock length is in meters. Okay, so that is all that. And now we got to just add that to the text field down here. So this is a little thing of MUI. I'll just click on this right now. There's a couple variants and things like that, but if I just hover over this, I'm pretty sure, let me see. Yeah, so down here you can see they have links to the API. So you can click on their API, you can open it, and right here you can see there's a bunch of things in here for configurations. It'll tell you how to do things. What we're going to want to do is we're going to want to add a thing to the input. It's called an input adornment. That's what we're going to add. So let me just find my old code that we're going to use here. Second. Okay. All right, I found the input adornment. All right, so now we slap the input adornment in here. This is what it'll look like. And we just got to import the input adornment. And bellamo, our units are there. Now if we save it and go back, you can see there's no units. Beautiful. Now I'll just add in the other units. Let's say it's like, I don't know, 4 kilograms heavier, and the center of gravity, I don't know, let's do 3. Center of pressure, I think that needs to be below it. Diameter, let's do 4.5 inches. Fuselage length, let's say this bad boy is 4 meters long, a huge and then it's got a pretty big nose cone. I don't know if this is accurate to anything at all, but let's hope it is. And then you can see over here, I'm going to go into the networks tab. So this will show all of our things that happen. So if I hit save, hopefully this will go and show something in here. Look at that. We got a post 200. So that means it posted properly. Here is our request. So it got all the values in here. We got a gravity of 3. That is 3. It got all the values. And then the response, it says the results, and it created it. And this is its ID. So now, if we go check our database, and we go check our, I gotta refresh. If we check our Rocket Sims, boom, there it is, right there. So now we have been able to create it. This is an old version, sorry. For some reason it's not closing. It created a second one. That was weird. Let's see. Okay, so one little bug happened here. It says, if success. I know what happened here. So error, this will return true if there is an error. There was no error, so success is falsy. So we just want to do the opposite of this. So we're going to have 3 of these now created. If I click save, it'll actually close now. There you go. So you can see there's a bunch of different posts. Yeah, so we have the same data but created 3 times. If we go back in here and we do, I think there's a refresh. Well, I'll just hit F5 and refresh it. You'll see there'll be 3 of the same data. And that'll be just retrieving them. Boom, we got 3 of them. So now let's just like grab one of these IDs. And we'll just show what it looks like when we want to edit. So if we go over to Rocket Details view and we go down to the dialog and we add an ID in here and we add the ID that I just copied. Oh, yeah, okay, so it's fine. It was just giving me, and we go in here and now we click on it. So now the ID is being passed into the dialog, and it'll be triggered when we hit this. You can see all of our things are in here perfectly. And now if we want to edit something, let's call it Simi, uh, and we click save. The patch has now went, and Simi, if we go over here, so right now before I refresh, they're all called Sim. If I refresh again, we have one called Simi. There you go. So that kind of brings us to the end here. We've kind of went through kind of everything you need to see when you're creating doing anything in full sec. So you kind of went from the creating the entity itself, creating the root, using the controller, adding to the server, and then defining the entity inside of the front end, updating the API, creating the component. For us, that was a dialog, and then creating a view. For us, that's just adding to a view already, and then adding our component to that view, and that's it right here. So that's kind of everything you should need to know to kind of the basics to get your feet wet. Try and go in and create exactly what I did, or if you were following along, hopefully you didn't run into any issues. If you did, uh, look at the full stack skill dev right here. We have the draft pull request. We'll have basically all the same things in it, but it'll also have a couple of other things. You can see I have added a alert in here. This is just for type security, or just to like show the user that it actually worked. Um, but yeah, so it'll be pretty much the same as what we just did here. Um, yeah, hope you enjoyed this. Let me know if you need any more help or anything like that. I'm Kris with a yellow name on Discord. Yeah, and that is all. Uh, Godspeed, Rocket. No, I'm not Scott. I can't say that. Anyways, goodbye.